thank you guys for joining us. We switched up in the schedule. We're going before Dr. Sachs, so sorry, but it's us now. I'm Kate Shepard. I'm an enterprise editor at the Huffington Post. In a previous life, I mostly covered energy and environment. I still cover it a little bit, but mostly I just sit at a desk all day. I'm pleased to be up on stage talking with Dr. Adam Sobel, who is an atmospheric scientist who specializes in the dynamics of climate and weather. He leads the Columbia University Initiative on Extreme Weather and Climate. And Dr. Peter Kellerman, who's a professor and chair of the Department of Earth and Environmental Sciences at Columbia. His primary research focus is on geologic capture and storage of carbon dioxide. Well, let's kick it off. Adam, your focus is on extreme weather and climate, which I think is a relatively easy way for people to understand the impacts of climate change, but is also one of those things that people always feel that they have to caveat. Climate and weather aren't the same. You know, we can't say that this exact event was caused by climate change. What do you want people to know about the relationship between climate and extreme weather?
It's difficult to give really simple answers that are scientifically precise at the same time. With some kinds of extreme events, we can already see fairly clearly the impacts of climate change. I think heat waves are the clearest example, where we've seen some in recent years that are outside the envelope of natural variability and of the type that our understanding of both the observations and our simulations of the present and past and future climate suggest we should be seeing. With other kinds of extreme events, on the other extreme, some events like tornadoes, we really don't have any evidence linking them to climate change, and then the others fall in some spectrum in between. With some very heavy rain events like the Louisiana floods of last year, there's some pretty compelling evidence that there's some role for climate change in those, and then others like hurricanes, it's still fairly contentious about whether we can see the effects yet, or whether that's just something we should expect for the future. And of course, with other kinds of extreme events like cold events, we expect them to become less severe as time goes on. So, I mean, the science of attributing individual extreme events to climate change is rapidly evolving. It's something that we used to say we couldn't do. We don't say that anymore. We can do it sometimes in a probabilistic and incomplete way. So there isn't a simple soundbite there. But I think the important thing is that climate change is here now. There are some impacts we can see now. There are others that we expect just for the future, even if they're not evident now. But the big picture is what's most important. And I think when we focus on individual events too much, it can be a distraction from that big picture where we have a comprehensive body of evidence suggesting the direction the planet is going. And so even though we do try to study individual events and understand their relation to climate change, it's important not to get too caught up in that, because it's in some sense the leading edge of the science where the uncertainties are the greatest, and there's so much that we do know with greater certainty that it's better to focus on the big picture.
And a related question is just how that motivates public understanding. I mean, after Superstorm Sandy, there was a lot of discussion that, like, maybe this is the event that really gets people to see that, you know, climate does impact U.S. civilization in a major way, even not necessarily the storm itself, but looking at, like, the surge and vulnerable infrastructure. And I felt like there was a bump afterwards where people really cared about it and thought about it a lot, and then I don't know that that continued after.
Yeah, there are a few different issues there. Sandy was an interesting example. There isn't strong evidence that the storm itself, Sandy, had a significant anthropogenic influence, human influence. The flood was about 8 inches worse due to sea level rise related to climate change. And that's a significant but small fraction of the total flooding. I think, though, that so some people, including the governor of New York State, immediately went out and said, "This is a huge climate change disaster." The scientific evidence really wasn't there to say that for the storm itself. But I don't think it's completely wrong to see some link there, in the sense that events like Sandy show the vulnerability that we have, even to the present climate. And in as much as we do expect some kinds of events to become more frequent or more intense, then we're not wrong in seeing these events some of these events as harbingers of what's coming, even if the links in the present aren't there yet. So it did elevate the debate for a little while, even if, you know, some of the debate wasn't as fully informed by the science as it could have been. And I think the deeper question you asked is about the interest fading over time. This is what we see with disasters. There's a short period where it really focuses people's attention, whether it's on climate change or just overall on the vulnerability. I mean, a lot of the things New York is doing now to protect itself from future events probably were worth doing even if there were no climate change. But that fades rather quickly, and I think one of the connections between weather disasters and climate change is independent of the scientific link between them, but is about the human perception. I mean, the climate change is an event that people see as far off in the future. It's sort of happening slowly all the time, and it's hard to focus attention and interest on that. And we see how that works with extreme weather events. When there's something right in front of our faces, we pay attention for a while, but then we get distracted by other things. And that the difficulty, and I think that's one of the reasons why attribution studies try to link them, because these extreme events are sort of teachable moments when it forces us to think about the environment we live in and some of the risks that it carries, and that's a good time to be talking about climate change regardless of what the specific links are. So I don't have an answer, but it is a challenging thing to sustain interest.
Peter, much of your research focuses on carbon capture and storage. What do you see as the promising developments here? What should we be following? I find myself getting more and more interested in this area as Washington gets less interested in policy.
Well, I do think actually, you know, the great machine of government is rolling forward. And so just in the past couple of months, some of the big carbon capture and storage projects that were started in the Obama administration have reached milestones where they're injecting, or they're getting to rates where they'd be injecting 1 million tons a year. And the Republican governors of Indiana and Ohio both just signed legislation that will require the states to reduce their greenhouse gas emissions in the next couple decades. So whatever we may be hearing from Washington, which isn't a totally clear message yet, a lot of good things continue to go forward. So those are things to watch. I think there is a perception that's a little bit more problematic on the part of industry, for example, that, oh, well, we know how to do this, and so we're just going to sit on the sidelines and wait until it pays, until there's a carbon tax or something. That's a little more insidious. It is a case that oil and gas companies inject globally about somewhere between 10 and 30 million tons of CO2 per year for enhanced oil recovery, so they certainly know how to get CO2 in the ground, but they also recover most of that with the produced oil and gas. There's only somewhere between 2 and 4 projects that were for carbon storage that are injecting at a rate of 1 million tons a year. And just to put that in perspective, in order to take up 10% of human emissions annually, we'd need 4,000 of those plants operating simultaneously. So there's a huge distance from where we are to where we would need to be. And indeed, one of the bigger projects, they cracked the cap rock. And so they had to stop injecting, and we don't really know how common that sort of event is going to be. I'd say from a purely sanguine point of view, as a scientist, if CO2 storage reservoirs leak a little bit, that's not a big deal. As long as we inject 100 times faster than they leak, it's really not terribly important. It's not particularly dangerous. And again, in the United States, a very, very high standard was set. I forget exactly, but like 99% retention over 50 years or something like that. Well, if you set that kind of objective, it's very, very difficult to even verify whether you've achieved it, and it becomes very expensive. So it'd be great if we could relax a little bit about that. As far as CCS goes in general, or carbon capture and storage goes in general, there's a big focus on the cost, and that's very well justified. So that the IPCC several years ago, for certain kinds of carbon capture and storage, they suggested it might double the cost of a power plant, and obviously that's significant. The costs are coming down, but another really important aspect of this is just philosophy and societal points of view, so that what's it worth? And in that context, it's very, very important that the previous administration did studies of the so-called social cost of carbon. I think they did a great job. I actually I'm amazed to say this. I think the White House did better than any of the previous academic studies of potential damage due to adding greenhouse gases to the atmosphere. There's beautiful diagrams with probability distributions and so on that are so much more meaningful than a saying it's exactly $40 a ton. And in that context, to the extent that that allows us to see what should a carbon tax be, what are different mitigation methods really worth to us, this is tremendously important. And I note that the Trump administration has canceled ongoing studies of the social cost of carbon. So that's for sure something to watch.
Related to that, I live in Washington, so I'm very Washington focused in my thinking, but one of the big concerns I'm hearing is just about government research and funding for climate science across the board. What influence do you think potential cuts there will have, and what are you hearing from colleagues who either work in government science or are funded by government science programs in terms of what kind of impact this will have?
Well, I'll respond to that, and then maybe Adam can jump in. But first of all, nothing's sure yet, and there's a lot of momentum and friction in the government system that will probably limit the cuts to some degree. And so you hear you hear lobbyists and other people who are very familiar with the legislative process saying, don't worry too much yet. But on the other hand, there are some programs within the U.S. research edifice that are being specifically targeted. And so being calm about the overall fate of the president's budget is one thing, but knowing that House Science and Technology Committee has recommended basically cutting all climate science research and moving NASA's Earth observing program entirely to planetary exploration, you know, those are the things to watch. And it may be that if they can isolate the climate science community and, you know, for example, fund NIH, they might succeed in some of these more targeted cuts. And again, that's something to keep an eye on.
Yeah, I mean, the statements of intent, I agree with everything Peter just said, but just to elaborate a little more. The statements of intent coming out of some parts of Congress, the House Science Committee, as well as the Trump administration, some of the things they've said they intend to do are pretty bad and would do lasting harm to climate science. I really worry, even if a fraction of that were to happen, it would have a really destructive effect on our, a lot of research at government labs and at universities, and I worry about the effect of young scientists coming into the field. You know, we could lose some very talented people who would choose other careers who we might otherwise attract into this field, and we need climate science to tell us what's happening and what will happen for the future. The science keeps evolving quickly, and we can't have science and foreign policy without the science. So it's true. The worst stuff being proposed probably won't happen in the full depth of its badness. but even a modest fraction of it would do serious harm, and so I really hope it doesn't happen. But as Peter rightly said, nothing's happened yet, and as far as our colleagues in government labs, I think they're all just waiting and seeing with a great deal of concern, but not panic just yet, for the most part.
I think let's take a polemical point of view. Let's do some politics in this room. So I think one of the most shocking things is to propose to basically cancel Earth observing by NASA. I mean, the satellite data are so much better at quantifying global trends over climate timescales than any other data sets we have, except maybe sea level. And a lot of that's satellite too. So the idea that we would stop the information stream because we don't like what we're hearing is, when you say it that way, is repellent, right? We don't like what the data, and so we're going to stop gathering data. It's shocking when you put it that way. Now you can clothe it in, well, planetary exploration is really exciting and we're finding all these exoplanets and we might discover the origin of life, and those are great things, but you should understand that clothing is sitting on top of a desire to simply cut off an information stream whose objectivity no one questions.
Okay, I'll go even further. I mean, I think, you know, the message, message we're hearing from now from Washington, which is really a message that has been there for a long time on the on the right among groups whose purpose is to deny the scientific understanding of climate change that we have. That logic is, whatever your political views are, it's just inconsistent and incoherent and hypocritical, because the message is simultaneously about the science, and you can see this in the Heartland Institute report that was just sent out to, I think, even to high school teachers all around the country, that says why climate science is actually more uncertain than the mainstream scientists say it is. The message is one of uncertainty and doubt. In other words, we don't really know, we're not as certain as the climate scientists tell us, and so you shouldn't be sure. But if you really believed that, you would want more research, right? You would want the observations to continue. You'd want to solve the problem. If the only way that cutting all these observations makes sense is if you believe that you already know the answer and there's nothing to worry about at all. That's a message of certainty. So it's really an incoherent message, and in some ways that message is more distressing. The fact that message seems to be able to persist from the highest parts of our government is more distressing than the specifics of the proposed cuts.
Yeah, I feel like, sort of related to that topic, what I find almost more dangerous than denial is making it seem like we can't know, and it's uncertain, and it just makes people, turning people off from the idea that we can know things and that maybe they should just disengage because it's too complicated and we don't know. And I find that just really scary.
It's surprising that message even works. So here's an analogy that's been used a lot, that I use a lot. Supposing scientists discover a large meteorite, and they say it's 30 years away, and there's a 30% probability that it will cross Earth orbit. Okay, well, the way science works is that all the ecological niches of opinion will immediately be filled. There'll be some people that say there's only a 5% chance. Some they'll say 99. And the sad fact is that the 5% people will be funded by the Heritage Foundation. But anyway, and we could talk about why that is. I mean, it's rational. But anyway, so that ecosystem will fill and people will be even more uncertain. So then what do? And you know that every year you wait, your information will get better. You could potentially avoid a giant outlay of funds. Every year you wait, it will become more difficult to deflect this object if it is going to hit the Earth. And there is a time, but you don't know when it is, when it will be too late. And I think, that's a really good analogy, and in some sense it can be paralyzing, but it's not paralyzing. So what do you do in the face of that situation? You start building rockets. You start experimenting with nudging things out of the way. You start taking action. You don't wait until it's too late. You don't even want to come anywhere close to that. And so it's puzzling to me that an argument from uncertainty is in some sense reassuring, or is an argument for inaction, because uncertainty in the face of annihilation is a reason to take action. Maybe not all the action, but some of the action.
On the issue of government science, I think the other thing that I find a little bit more troubling than just the straight cuts to the programs are the hiring freeze, and the idea that it's going to be a lot harder for young scientists to get into government, or even that they would want to get into government. I mean, if you looked at it right now and you were leaving with a PhD, would you necessarily want to go work at the EPA right now? I don't know. What do you guys see as the path for young scientists right now who care about these issues and also want to be relevant to policy?
You go.
It's a tough one. I've been struggling with that. I mean, I think we have to believe that some sanity will return. I don't know what the alternative is. I mean, and the other way to look at it is, well, I mean, at least for those of us, let's start with the old people. I mean, for those of us who are already invested in the system, and who already, have careers as scientists, I think what we have to tell ourselves is that the work we're doing is important, even if some powerful people in the society don't want to recognize it, and it's our responsibility to keep doing that work in the hope that it'll be used and valued. And I hope that message will be compelling to young scientists as well. Obviously the risks are greater for them, but I know that when I see our students and our junior scientists, there's also a tremendous motivation and passion and idealism, and I hope that that will sustain them through this period.
So I've composed my thoughts now, and I'll say a few things. I used to always canvass classes in high school groups when I would speak to them, and I would ask them if there were an energy corps or a climate corps, would you volunteer 6 months of your time or a year of your time to participate? Let's suppose it's a subsistence wage and housing. And I first started thinking about this a long time ago when President Carter compared the first oil crisis to war. He said it's the moral equivalent of war, and that was, we were not very far post-Vietnam, and I thought, okay, so we're gonna have a draft, and we're gonna have universal service, and we're gonna have people going out and doing all the grassroots ways of basically conservation, insulating houses, installing solar, and so on. And it didn't happen, and it was a plank in the Obama campaign in 2008, and it didn't happen, and I'm not really sure what the reasons are, but if you like that idea, you might try and join me in promoting that idea because it fulfills a lot of needs. It provides people with an opportunity to put their oar in the water. We're not all going to be specialists at installing those solar panels, but I'm quite sure everyone in this room could learn how to do it in a few days, and then it would be an extremely effective thing to do. So I also think if we look back, so people are very poor at dealing with slow-moving emergencies, right? And that's famously part of the climate problem. So, but if we look back at successful responses to slow-moving emergencies in this country, civil rights is the most obvious thing that comes to mind. And what you saw there was that the public was very moved by evidence that senior leaders and young people were actually willing to make personal sacrifices and really pay a price individually in order to change the laws and in order to raise public perception. And I think we may be going into a period where it's necessary and in some sense easier to take that kind of stand. You know, in the Obama administration, who were we against? The president basically agreed with us. But we're now in a situation where there's actually things happening that could warrant civil disobedience, could warrant a kind of very, very active opposition, and offer the opportunity to make personal sacrifices that demonstrate how much we are concerned about this. So, and it won't be the clergy, right? So it's interesting to ponder the science community. We traditionally try and stay out of politics. It's interesting to ponder, if not us, then who?
You did an excellent job of leading into my next question, which was, we have a scientists' march on Washington coming up here in about a week. We have a climate march the week after. It's going to be a pretty busy time of marching. What do you see as the role of scientists right now in pushing both the public policy debate, but also sort of general public awareness on this issue?
Oh, that's such a difficult, you know that's hard, right? Because we are clinging to the shreds of our public reputation for objectivity and for dispassionate advice. We are not politicians. We don't want to be accused of being politicians, and that puts us in a very difficult situation when we see the government actually becoming anti-factual. So would it be okay if I stopped there? I'm going to march, but...
You are?
Yeah, but I certainly understand
What's your sign
the hesitations there.
What's your sign going to say?
What's my what?
What's your sign going to say?
Oh, I haven't composed a sign yet.
Yeah, I'm going to march too, and I don't have a sign yet either. But, you know, I think in climate science for a lot of years, many of us avoided getting directly engaged in the political debate for all the reasons that Peter just said. I mean, we want to have the reputation for objectivity and dispassion. But I think, I mean, for many of us, this transition had been occurring away from that view and towards a more active and engaged public stance had been occurring for some time. But now, especially when we see, you know, in the highest parts of the U.S. government, and elsewhere in the world to a lesser extent, such opposition, not just to specific policies, but to the whole enterprise of science and the whole use of evidence in policymaking, it becomes easier to feel the need to be engaged or harder to stay out of it. I mean, because the principles are so basic that we're talking about. I mean, the principles of facts, evidence, and the scientific method are so basic that you don't really have to be an advocate for a specific policy to think that's important. So I think we're going to see a lot more activism. I mean, when it comes to climate per se, though, I think there's also just a general sense that, who are we kidding? We're human beings too, right? And we study these data and these bits of evidence and the whole picture coming out of all the tools we use, the climate models and everything else, to understand this story. And it's just impossible, if you do that, to come away not thinking that we have a problem and we need to do something about it. We can argue about exactly what. And I think scientific entities like universities and professional societies are right not to get too in the weeds of advocating for specific policies, but in terms of advocating for a science-based approach, and in the case of climate, for the need to do something rather than opposing all action, as the White House currently is at this point, it's a no-brainer.
So we're in a room, oh, sorry.
Go ahead.
We're in a room full of young, emerging intellectual leaders, business leaders, entrepreneurs, aspiring entrepreneurs. What do you see as the areas of biggest potential for growth or innovation or new insights and that you think will inspire these folks going forward?
Energy storage. So the renewables transition, I'll just say from the stage as somebody who works on carbon capture and storage, the renewable transition is much more important and far cheaper in the long run than cleaning up later on. So anything you can do to participate in the renewable energy transition, that's going to be a tremendous growth area. We can already see that as solar PV in particular reaches grid parity with fossil fuel electric generation in some markets, when that really happens, it will suddenly burst exponentially. And the only thing then that's limiting is energy storage. And that's a very, very important limiting factor. But frankly, again, it comes down to choices and values. We can do it. It's not optimally efficient. It does add to the cost, but compared to what? And again, we need rational cost-benefit analyses of these things, but I'm pretty sure that it's cheaper to even use an inefficient energy storage system and go all the way on renewables than it is to sit around and wait burning fossil fuels. So I think there's a real potential for making lots of money participating in the energy transition, and also the transportation transition, using personal vehicles as batteries while they sit around all day, engaging in conservation with more ride sharing and things like that. These are all things that are becoming very, very possible. They're pretty much in the forefront of entrepreneurial organizations already. These are all big opportunities.
Yeah, I mean, I think, absolutely agree. I mean, one of the things we have seen already about this renewables transition is, I mean, we don't know exactly when it's going to happen on the large scale that Peter just described, but almost certainly it's going to be much sooner than anybody thought a few years ago. The price of solar is already below the price of fossil fuels in a lot of the world. And so the storage and the grid transmission issues are the issues, and that's where the breakthroughs are most urgently needed. The price of the panels itself is already dropping very fast. Wind has potential too. This is going to happen, and it would be great if we had some leadership from government, but it's going to happen anyway. And there's already a lot of things happening at the state and local level. Of course, the private sector, a lot of people recognize there is money to be made on it. So yeah, if I were a young person going to this, that's certainly an area for scientists to work on.
We have about, I think, a minute and a half left, so lightning last answer. What keeps you going? What makes you excited to do your research every day? What do you see as the big exciting thing on the horizon?
That could be so incredibly arcane for me to answer that. But You know, there are basic science questions that feed into carbon capture and storage, for example, involving feedbacks between reaction and cracking and permeability and so on that also have applications across all of earth science and plate tectonics and all that. So, you know, when I wake up in the morning and think about a grant proposal, I'm usually looking at those basic issues.
I mean, I study the basic physics of how weather systems work and how the climate works, and the motivation for doing that primarily is the same as any other scientist's motivation. You get deep into it, and it's a fascinating problem, and the joy of discovery is the primary motivator. But for those of us working in this field, and it's to some of us, it's something that helped draw us into it, the feeling that we're participating in a activity that is also important to the prosperity of the planet and our society is another source of motivation that doesn't hurt either.
I've been sitting here wondering, when I retire, will I go into politics? And my only concern is I'll be so bad at it. I like to put my worst foot forward, as Adam well knows, and I wouldn't be able to break that habit.
Maybe it's a recipe for success nowadays.
Adam and Peter, thank you so much for joining us, and thank you all for sitting through this.